you're going to die without ever leaving this galaxy. And that's actually fine. Look, I know we love to imagine ourselves as space explorers. We've got movies where we zip between galaxies like they're subway stops. We've got billionaires building rockets and talking about making humanity multiplanetary. But here's what nobody wants to admit. We're trapped. Not because we lack ambition or technology. We're trapped because the universe is so insanely big that even our wildest dreams are basically jokes. Let me show you what I mean. Andromeda is our neighbor, like literally the closest major galaxy to us. It's 2.5 million light-years away. Now, that number gets thrown around a lot, and it sounds kind of manageable until you realize what it actually means. A light-year isn't a measurement of time, it's distance. Specifically, how far light travels in 1 year. And light doesn't mess around. It moves at 300,000 kilometers every single second. That's fast enough to lap the Earth 7.5 times in 1 second. In a year, light covers about 9.5 trillion kilometers. So when we say Andromeda is 2.5 million light-years away, we're saying it's 2.5 million times 9.5 trillion kilometers away. Do that math and you get roughly 24 quintillion kilometers. That's 24 with 18 zeros after it. Your brain literally cannot process that number. Mine can't either. We didn't evolve to understand distances like that. We evolved to know how far the watering hole is or how many steps to the next village. Our brains max out at maybe visualizing a few thousand kilometers. After that, it's just noise. But let's try to break it down anyway. The fastest object humans have ever created is the Parker Solar Probe. This thing is hauling. It moves at about 700,000 kilometers per hour. That's fast enough to fly from New York to Tokyo in less than 30 seconds. It could circle the entire Earth in under 3 minutes. It's absurdly fast by any human standard. So how long would it take the Parker Solar Probe to reach Andromeda? About 4 trillion years. Let me say that again, 4 trillion years. The entire universe is only 13.8 billion years old. That means this journey would take roughly 300 times longer than everything that's ever existed. By the time you got halfway there, the sun would have exploded, Earth would be a memory, and galaxies would have crashed into each other and formed entirely new ones. And you'd still have half the trip left. Okay, but what if we go faster? Let's get unrealistic. Let's imagine we build a spaceship that can move at 10% the speed of light. That's 30,000 kilometers per second, faster than anything we've remotely figured out how to build. At that speed, you'd cross the entire solar system in hours. You'd think, finally, we're cooking. Nope. Even at 10% light speed, the trip to Andromeda would take 25 million years. 25 million years ago on Earth, humans didn't exist. Our ancestors were small apes hanging out in trees. If they had somehow built a rocket back then and launched it toward Andromeda, it still wouldn't have gotten there yet. That rocket would still be flying right now, millions of years later, with millions of years still to go. And that's at 10% light speed, which again, we have no idea how to do. All right, fine, let's just cheat. Let's say we hit actual light speed. We break every rule of physics and somehow move at 300,000 kilometers per second, the cosmic speed limit. Even then, it would still take 2.5 million years. And by the way, you can't actually do this. Anything with mass can't reach light speed. As you accelerate, your mass effectively increases, and the energy required to keep speeding up approaches infinity. You need infinite energy to hit light speed, and infinite energy doesn't exist. It's a wall you can't break, not because we're not smart enough, but because the universe said no. So there's no speeding our way out of this one.
This is where people usually jump in and say, okay, but what about warp drives? What about wormholes? What about all that stuff from Star Trek? Yeah, let's talk about that. A warp drive doesn't technically make you go faster than light. Instead, it bends space itself. You shrink the distance between you and your destination. It's like folding a piece of paper so two dots touch. You're not moving faster, you're just making the road shorter. Cool idea. One problem. You'd need an absolutely insane amount of energy to do it. We're talking more energy than every star in the galaxy produces combined. And right now, we can't even figure out how to generate a fraction of that. Warp drives exist in math equations and sci-fi shows, but not in reality. At least not yet. Maybe not ever. And wormholes? Same deal. In theory, they might exist. Shortcuts through space-time that connect two distant points. But if they do exist, they'd be wildly unstable. They'd collapse the moment you tried to use them. And even if you could somehow hold one open, the gravity inside would stretch you into a thin strand of atoms. Scientists call it spaghettification, which sounds funny until you realize it means you'd be ripped apart molecule by molecule. So no, we're not warping anywhere, and we're definitely not diving through wormholes. But even if you could somehow move fast, space itself would kill you. Out there, you're dealing with lethal radiation. No atmosphere, no magnetic field to protect you. You'd be bombarded constantly. Then there's the temperature. Space swings between boiling hot and freezing cold depending on where you are. And those tiny dust particles floating around? At high speed, they become bullets. At just 10% light speed, a single grain of sand could punch a hole straight through your ship's hull. Now add in the fact that you need food, water, oxygen, and something to do for 25 million years. You'd need a ship the size of a city. You'd need to grow food, recycle everything, and keep people alive across thousands of generations. Every person on board would be born, live their entire life, and die on that ship. Their kids too, and their kids, for millennia. It's not a journey. It's generational exile. It's a prison that moves. But here's the twist. You don't actually have to go to Andromeda. Because Andromeda is coming to you. Right now, Andromeda is moving toward the Milky Way at about 400,000 kilometers per hour. In about 4 to 5 billion years, the two galaxies are going to collide. Astronomers even gave it a name already, Milkdromeda. When it happens, the night sky will look completely different. Millions of new stars will light up overhead. The view will be breathtaking. But here's the thing. You won't see it. I won't see it. Nobody alive today will. By the time Andromeda gets here, the sun will be dying. Earth will likely be a scorched husk, uninhabitable, dead. Humanity will either be long extinct or so changed we wouldn't recognize ourselves. So yeah, Andromeda's coming, but we'll be gone. And honestly, that's okay. Because talking about Andromeda isn't really about getting there. It's about understanding scale. It's about realizing how staggeringly huge the universe is and how tiny we are inside it. We spend our lives measuring things in feet, meters, miles, a commute, a road trip, maybe a flight across the ocean. That's our scale. But space doesn't care. Space operates on numbers so massive they stop feeling real. You could build the fastest ship imaginable, and space would barely notice. But that's what makes it so beautiful. When you look up at Andromeda tonight, and yes, you can see it with your naked eyes if you're somewhere dark, you're seeing light that left that galaxy 2.5 million years ago. You're literally looking into the past. That light has been traveling through the void for longer than modern humans have existed just to reach your eyes right now. And flip that around. If there's someone in Andromeda looking back at us right now, they're not seeing you. They're not seeing cities or cars or the internet. They're seeing Earth as it was 2.5 million years ago. Early humans, maybe. Stone tools, forests, animals. No skyscrapers, no planes, just raw, wild Earth. That's the thing about light. When we look across galaxies, we're not just looking across space, we're looking across time. So no, you'll never reach Andromeda. Even light takes millions of years to cross that gap. But you can see it. You can look up, find that faint smudge of light in the sky, and know that you're connected to it. Across time, across distance, across everything. And honestly, that's enough. That tiny blur you can barely see, that's a galaxy with 1 trillion stars. It's been there for billions of years, and it'll be there billions more. You get to witness it, not by going there, just by looking up. That's not a failure. That's a gift. So the next time someone says humans will visit other galaxies someday, you can smile and say, we already do, every time we look up. You'll never reach Andromeda, but that light reached you. And that, right there, is the whole point.